Okay, now we're going to do type 2. Again, these are just my own little classifications. Integration by parts is just how to take an integral and use this integration by parts of this u and dv. So type 2, I'm going to call let u equal the function you know how to take the derivative of, and let dv equal the rest. So let's first talk about ln of x. So I know that the derivative of ln of x is 1 over x. So make sure that you know it goes this direction, right? The integral of 1 over x dx is ln of x. Integral of ln of x dx, we can't do yet, okay? So make sure that you're not taking the antiderivative of ln of x. The derivative of ln of x is 1 over x, because we're doing derivative and integral at the same time, so make sure that you're not trying to do this, correct? Okay, so let me get rid of that, and let's go and dig into this one here. Oh, I'm going to do the integral of ln of x right here and now, okay. So this I'm going to let equal to u, because I know the derivative of it, I don't know the antiderivative of it. And so this one, it's like the simple case. The dv is just going to be the dx. So when I take the derivative of u, I get 1 over, a derivative of u, which is ln of x, I get 1 over x dx. The antiderivative of dv is v. The antiderivative of dx is x. So let me just write that here so you can see. So this is like saying, what's the integral of 1 in dv? That's v. The integral of 1 with dx, that's x. So that's how it turns into v equal x. It's kind of the simple case, which kind of makes it the simple hard case, which makes you feel stupid, like where did it come from? It's just the antiderivative of 1 to get x, or v. All right. So let's put it together. So I have uv minus the integral of v du. Wait a minute, x times 1 over x, that just gives me 1 inside the integral. The integral of 1 dx is just x. So there it is. That's the antiderivative of ln of x dx. All right, so now what do I do with x times ln of x? Okay, this is not like type 1, because I do know the integral of ln of x, but I'm not going to do parts within doing parts. So that's where I let u equal the one I know the derivative of. Again, this is just my own little words, my own little pattern, but let u equal the ln of x, because I know the derivative of ln of x. And I'm going to let dv equal the rest. So the rest is x times dx. So remember, you're taking the antiderivative on this part. So the antiderivative of dv is v. The antiderivative of x, increase the exponent when you're taking the integral, right? So I get x squared over 2. So let's put it together. So uv gives me this, minus the integral of v du. So then I got to cancel the x's. So I get x over 2. I know the antiderivative of x over 2. That's the same thing as saying 1/2 integral of x, correct? So I carry this first part along. And so I'm going to take the antiderivative of x and get x squared over 2. So I get 1/4 x squared plus a c. Okay. Here we are, arctangent. So you have to know that you know the derivative of arctangent. That's 1 over 1 plus x squared. This is a big deal. It's going to come up a lot. And while we're talking about it, you need to know the derivative of arcsine. This is going to come up a lot. It's this one. These two you need to know and recognize. So we know the derivative of these two inverse trig functions, not the integral. So the integral of that, we're going to do parts and let u equal the trig function. And dv will equal the rest. Again, dv is just dx. So antiderivative of dv is v, antiderivative of dx is x. So again, the derivative of arctan is 1 over 1 plus x squared. So now I'm ready to do parts. So it's uv, I'm sorry, I pointed at the wrong thing. uv, these two things here, x times arctan, minus the integral of v du. So I have x times 1 over 1 plus x squared dx. Okay, two functions multiplied times each other. You can't just go take the antiderivative of them each. But because you know u substitution so well, you're looking at this and say, oh yeah, if I let u equal the denominator, du is 2x dx. So then 1/2 du is x dx. So x dx, the numerator, gets replaced with 1/2 du. And I have 1 over u for letting u equal 1 plus x squared. I know what that integral is. That's ln of, make sure you put the absolute value bars there, absolute value. And then I'm going to take the last step and put the u back in, so you get 1 plus x squared. And then put the plus c at the end. Okay, so this one here, I want you to pay careful attention to. So this one, there's lots of mistakes that are made. So this ln squared. Okay, so there are properties of ln. So when this power here is just on the argument, this is equal to 2 times ln of x. This 2 here is on the outside with big parentheses, so this does not come down. Okay, so with integration by parts, we have to let u equal the whole function, and then dv equal the rest. So dv is just the dx, and here the u is equal to all of this, ln of x quantity squared. So to do the derivative of this, we need chain rule. So you bring the 2 down in the front, you carry ln of x along to the 1 power, I didn't write it there, but then take the derivative of ln of x, which is 1 over x dx. So be really careful. Lots of people make mistakes on problems like this. So antiderivative of dv is v, antiderivative of dx is x. So now I'm going to put it together. U and v minus the integral of v, which is x, times du, 2 ln of x times 1 over x dx. That's a big ugly thing, right? Oh, let me see if I can make that bigger so I can see it better. Okay, get rid of this line. Okay, so I've got integral of x, 2 ln of x, 1 over x dx. Take time to fix this, right? So I'm going to pull this 2 on the outside. This x in the denominator cancels with this x here. Oh, look at that. I'm just left with integral of ln of x. So you could go do parts again on this, but since we just did it up here in example 1, you could just pull this along and say, oh, I know it's x ln of x minus x. So this integral here, right, with the 2 in the front, the minus 2 in the front, that I do parts on again. Some people like to memorize that. It's up to you.